Hello class, this is Mrs. Gallegos, and today's tutorial is going to be about mole conversions. This information can be found in Chapter 11 of your textbook. Conversion basics. So here I have 3 eggs. These 3 eggs can be described with different units. So for example, I can describe them as 0.25 dozen, but there's still 3 eggs. Or I could describe them as 150 grams if each egg is 5 grams. Then they're 150 grams, but there's still 3 eggs. Or I could describe them as 3 yolks, since each egg has 1 yolk in it, but there's still 3 eggs. Or I could describe them as 21 grams of protein, because each egg has 7 grams of protein in it, but there's still 3 eggs. So how do I go about changing the units or dimensions of a certain amount of anything? Well, I'm going to use equivalences, or what we're going to be calling from now on conversion factors. So with eggs, I can say that 1 egg is equal to 50 grams. This is an equivalent. I can turn it into a ratio because these two numbers are equal, and any number over itself, or its equivalent, is equal to 1. I can also, if I want, express the ratio as 50 grams over 1 egg, and it still maintains that value of 1. Well, I'm going to use this mathematical trick to change the units of my amount without changing its value by just simply multiplying it times these ratios of equivalences. So what we're going to be doing, these conversions are basically dimensional analyses. I'm going to use a series of equivalent measurements as conversion factors to change the description of an amount without changing the absolute value. The tool that I'm going to be using to do this is called the picket fence. This picket fence will be helping us to determine, once we put in our conversion factors, if we're going to be multiplying or dividing by those conversion factors. So for example, if I start out with 3 eggs and I want to convert them to grams, I have an equivalence of 1 egg is equal to 50 grams. I analyze my dimensions, and I'm going to place the ratio into my picket fence so that eggs will be in the denominator and the numerator, and I will be able to reduce them to 1, leaving me with just grams. And so the math that the picket fence tells me to do with these numbers is to multiply 3 times 50 grams and then divide by 1. And so my answer is 150 grams. So this is how we use the picket fence to help us do dimensional analysis, or do conversion by dimensional analysis of these equivalence ratios. So what ratios will we be using in chemistry? Well, we're going to be using the mole and its equivalences. So 1 mole is equal to 6.02 times 10 to the 23rd particles, and those particles can be ions, atoms, molecules, or formula units. We also know that 1 mole is equal to the relative atomic mass, but instead of being in atomic mass units, now it will be in grams. The same can be said for formulas. 1 mole is equal to the formula mass in grams. We can also use these beautiful things called mole ratios. Mole ratios can be found in the formulas, or they also can be found in balanced chemical equations. So for example, I know that 1 mole of calcium hydroxide is equal to 2 moles of hydroxide ions, and I see that by my subscript of 2. I can also say that 1 mole of calcium hydroxide is equal to 1 mole of calcium ions, and I see that because calcium has a 1 subscript, and we don't write 1 subscripts. I could also go to a balanced chemical equation, and I could come up with more mole ratios. This time I'm looking at coefficients. So this balanced chemical equation tells me that 2 moles of water will be equal to 2 moles of hydrogen. And I can also say that 2 moles of water is equal to 1 mole of oxygen. And I don't know why there's a 2 in front of the water. It should just say 2 moles of water is equal to 1 mole of oxygen. So I can get these mole ratios from either the subscripts in a formula or the coefficients in a balanced chemical equation, and use them to do dimensional analysis, conversion by dimensional analysis. So let's put this to work. Sample problem. My first problem is going to be a mole particle conversion. So I want to convert 3.2 moles of calcium hydroxide into formula units, which are particles for ionic compounds. So I put my 3.2 moles of calcium hydroxide into the upper left-hand part of my picket fence. Now I'm going to look for an equivalence that will help me describe the relationship between moles and formula units. So I have it. It's Avogadro's number. 1 mole is equal to 6.02 times 10 to the 23rd particles. I turn this equivalence into a ratio, and I analyze in a way so that I can analyze my dimensions and reduce my similar dimensions to 1, leaving the dimension that I want. The math I'm going to do is 3.2 times 6.02 times 10 to the 23rd divided by 1 mole, and that will give me 1.9 times 10 to the 24 formula units of calcium hydroxide. Next problem is a mole mass conversion. This time, instead of converting from moles to particles, I want to convert from moles into grams. So I put my 3.2 moles of calcium hydroxide in the upper left-hand part of my picket fence. Now I look for an equivalence that shows me the relationship between moles and grams of calcium hydroxide, and that's going to be the formula, the molar mass, the formula mass. So 1 mole of calcium hydroxide is equal to 74.1 grams of calcium hydroxide. I analyze my dimensions and I put in my equivalence as a ratio so that I can reduce my similar units to 1 and be left with the unit that I desire, which is grams. My math will be 3.2 times 74.1 grams divided by 1, giving me a total of 240 grams of calcium hydroxide. The next conversion is a gram-mole conversion, so the opposite. This time, I'm starting with grams and I want to convert to moles. So I put my given amount, 140 grams of calcium hydroxide, into my picket fence. Now notice this time it's not asking me for moles of calcium hydroxide, but it's going one step further and it wants to know how many hydroxide ions are in 140 grams of calcium hydroxide. So this is going to require 2 equivalences. My first equivalence is going to tell me the relationship between grams and moles. So I make my equivalence into a ratio. I analyze the dimensions so the like units will cross-cancel or reduce to 1. Now I have moles of calcium hydroxide, but the problem is asking me for moles of hydroxide ions. So now I use that ratio of my subscripts in the formula, and I know that 1 mole of calcium hydroxide will produce 2 moles of hydroxide ions. So I put like units so that they can cross-cancel. And I am left with just the units of moles of hydroxide ions. My math is 140 times 1 times 2 divided by 74.1 times 1, which will give me 3.8 moles of hydroxide ions. And if I do mental math, this makes sense to me, because 140 grams is 2 times as much as 74 grams. So I know that 140 grams is going to be about 2 moles. But I know for each mole of calcium hydroxide, there's twice as much hydroxide ions. So I know that's going to be 2 times as much as 2, which is 4. And I see that my number is around 4, 3.8. So it's always good to do mental math to see if you're in the right neighborhood with your answer. The last conversion we're going to do is a mass-particle conversion. This conversion is going to take us from mass to formula units, which were our particles, if you remember. So I'm going to plug my given into the upper left-hand part of my picket fence. Then I'm going to look for equivalences that will help me move from the units I have to the units I want. In this case, I want formula units. So I have my 1 mole is equal to 74.1 grams of calcium hydroxide. I make it a ratio so that my like units cross-cancel and I'm left with moles of calcium hydroxide. Now I need a relationship between moles of calcium hydroxide and formula units or particles of calcium hydroxide, and that will be Avogadro's number. So again, I make my ratio and put it into my picket fence so that I can reduce my like units to 1 and leaving the desired unit, which is formula units. My math that I'm going to be doing is 95.6 times 1 times 6.02 times 10 to the 23rd divided by 74.1 times 1 mole. And that will give me a total of 7.77 times 10 to the 23rd formula units of calcium hydroxide in 95.6 grams. I hope this tutorial has been useful. Remember, if you're still having trouble, to come and see me during office hours on Monday afternoons.